think I started to give you more space, but on this one, yes, this is the first one that I actually gave you enough space for in your notes. So we're going to do these composite objects again. So the surface area of composite objects, the idea that we've been having is I take both those pieces, I dip them in white paint, I pull them out, then I break them apart. And I would have all of the surface area of the bottom shape, all of the surface area of the top shape, but when you break it apart, there would be two things that aren't painted. So we color-coded this, and we started with, what's the big idea for this one? The surface area will equal, and I'm going to color-code the rectangular prism here in blue. If we figured out the surface area of the blue one, and then I'm going to color code the cylinder in green, and we added the surface area of the cylinder, we need to subtract, and when I break them apart, can you see that right here there would be a circle missing on the blue shape and a circle not painted on the green shape? So we need to subtract. I'll put the circle in brackets because otherwise it looks like I'm subtracting 20. So, after you've got your big idea, now we have to do each of those small ideas separately. And I'll color code them again. First small idea was the rectangular prism. We go to our formula sheet. Sometimes the formula sheet is nice and gives you a formula. Sometimes the formula sheet says, just add up all the sides. So then you have to think about breaking something apart and adding it up. For rectangular prism, we have a formula on our formula sheet, which says 2LW plus 2LH plus 2HW. So we need to decide what's our height, what's our length, what's our width. So off to the side here, I would look at my diagram. It looks like my height is 8 centimeters, my length is 12 centimeters, and my width is 5 centimeters. So then I can just plug things into my formula. Length is 12, width is 5, plus 2, length is 12, height is 8, plus 2, height is 8, width is 5. So take out your calculator. Type that whole thing in all at once. Okay, because I just did that quick mental math. I need to find out how far off I am. Did it work? Oh, you typed something in wrong. Let's try it again. So where the things are in brackets, see how I have a 2 and then a bracket of 12, a bracket of 5. In your calculator, you could either do the brackets or you can just multiply in between and go 2 times 12 times 5 plus 2 times 12 times 8 plus 2 times 8 times 5. Did it work for you, 392? Excellent. Got it? Okay. It's excellent because that means I also did the mental math right, which makes me happy. Okay, little idea number 1, done. Little idea number 2, that was the cylinder. Switch my colors to green. So If you're using pencil all the way through, maybe you number these just to keep them separate and draw, okay, draw a straight line across here and now number little idea number 2. Because now we need to find the cylinder.
You got 1080?
No, let's see what it.
Okay. Yeah, I'll let it go.
I just want to see. Oh, he's just 2 times 12 times 5, 2 times 12 times 8 times.
No, yeah, he needs 2.
But I don't know why his is so. Oh, he has 2 times 12 times 8 times 5.
There you go.
Yeah. Oh, yeah, and on our formula sheet, we have that formula on our formula sheet for surface area of a cylinder. So we need to say, what is h equal to? Well, the height of that cylinder is 6 centimeters. What's the radius equal to? Well, the question doesn't show us the radius, but it shows us the diameter. Does it make sense that if the diameter was 4 centimeters, your radius would be 2 centimeters? So our surface area of this one would be 2 times pi times 2 squared plus 2 times pi times 2 times 6. All right, now this one, you're going to need your calculator. Yeah, pi, you got to take out your calculator. Did you get, when you type this one into your calculator, 100.53? Yes? No? Did that work when you typed it in your calculator? Double checking that we got the same answer? Okay, so now I could draw a line here, and I'm going to switch colors. You might be numbering it. This is little idea number 3. We have to subtract 2 circles. Your area of a circle formula is pi r squared. And what's the r in the circle? It's equal to 2 centimeters. So our area. So these questions can be very difficult if you don't approach them in an organized and systematic way. Because there's a lot of things we have to do. Probably, I'm going to argue this might be a question that you have to show the most math that you've had to show for any math question you've done ever. Can you think of any other math questions you had to show this much work for that you've done in grade 9 or grade 8 or grade 7? Okay? So, type this one into our calculator. Did you get 12.56? Well, I guess if I round it, 12.57 centimeters squared. Draw a line. Now we can go back to the big idea. And our total surface area will be the blue one, which we figured out was 392. Plus the green one, which we figured out was 100.53. And then we had to subtract 2 of the red one, 12.57. Go to our calculator to do this. Now, for some of you next year, if you take pre-calculus next year, you would want to make sure that when you use your values on your calculator, you don't round until your final answer. So you want to take all the decimal places that you had before. And then when you get to your final answer, surface area equals 467.4 centimeters squared. So I'm going to zoom out here so we can see the whole screen. Okay? And what I want you to notice is how we organize this. Because when you're on a test, right, if you don't organize a question like this, very easy for you to make a mistake. Okay? So I started off with the big idea of what I needed to get. I needed to get the whole surface area of the blue one, the whole surface area of the green one, and then subtract the two circles, because if you dropped them in paint, pulled them out, and popped them apart, there would be two circles that aren't painted. One on the bottom of the cylinder, and there would be a circle on the top of the prism. So I have my big idea. Now that I've got my big idea, I can go to those small ideas and do each one separately. I color-coded it, but if you're working on a test, you usually just have pencil, so you might like to number it. I drew a little picture, so I'm like, this is the first thing I'm going to do. Did my formula. I drew a line to sort of separate. That part is just for my surface area of my rectangular prism. You might even want to circle these things as you go along. Okay, there's my one answer. Here's my surface area of my green one. Here's my surface area. Here's my final answer. There's actually something quite satisfying about circling answers. I'm not sure what it is, but that felt really good.
It always throws me off when I do the cylinders, but I do it without the 2 pi r squared because I know I'm going to
Oh, yes. Here, just one second.
Just weird.
Yeah. All right. So, organized 1, rectangular prism, 2, the cylinder, 3, the circle. And then I went back to my big idea and said, what do I need to do? I need to add my surface area, which I did in blue, plus the green. I wrote that in green. And then, I have to take off 2 of the circles. And I had just done 1. Okay? So this was the big idea. Mr. Shirk was just saying, if you know how the formulas work, he noticed, and I'll put it in yellow here, that the surface area formula has 2 circles built into it. So some people just take that out right away and then not do this part. Okay? But you have to really know your formulas to do that. It might be better to have your big idea set up and do it systematically. But if you like that as a shortcut, do people understand that shortcut? If you took this out, I'll put an X through it, then you wouldn't have to do all of this, which would make it shorter.
But if you don't know it, and it messes me up too because I take off the 2 circles, but there's still a circle on top.
Right, it kind of messes because
But
in your
even though I know I just now it then I have to know.
Yeah.
Okay, well, it's still part of that top piece of the rectangle if I look down.
for visualizing it, I like this better because it really helps you see. Okay, this is what I've done. Okay, yeah, I got to take off these 2 circles. All right, here's our next question. Yeah. I'll just grab that right here. Thank you. Okay. I guess technically this line shouldn't be here, right? When I was drawing it on Word, it could only do so much for me on Word. Okay? Yeah, some of the formulas are not the most helpful, are they? Big idea? I'll take it right here. Perfect. Big idea to figure out our surface area. Okay? I'm looking at this. I'm going to figure out the surface area on my rectangular prism. And then I'm going to add the surface area of my triangular prism. And then I'm going to have to subtract. Well, if you stick them in glue and then pop them apart, can you see that there would be two rectangles that would have to get subtracted. There's our big idea. Now we go to our small ideas. Woo. Small idea number 1 was the rectangular prism. Again, we have a surface area formula for this. I always have to pull out the formula sheet for this one because I have it memorized, but the letters don't necessarily match up with how it is on your formula sheet. Because can you see that it doesn't matter the order that I write how they're added? Yeah. And it wouldn't matter if I wrote the W first or the H first. So I just, for consistency, I want to write it exactly as you see it on your formula sheet, so you get used to that. And then off to the side, every time we have a formula, it's good to list what do we know. I know my height is 20 centimeters. I know my length is 30 centimeters. And I know my width is 15 centimeters. Now, what if you decided the width was the 15 and the length was the 30? Oh, no. If the length was the 15 and the width was the 30, it wouldn't matter. Okay? Because you can turn a rectangular prism to make whatever side your height. Okay? The formula will still work for you. But now we just have to go through and plug in. And this is where the letters do become important. You have to make sure that you're plugging the right numbers in the right place. All right, I need someone to verify. That was a little quick that I did. I probably made a mistake. That is correct? All right. Circle this right here. Draw a line because we've now figured out big idea number 1. Switch colors. Or since you're using pencil, you're going to write small idea number 2, not big idea number 1. Small idea number 1. Now I'm going to do my triangular prism. So I go to my formula sheet, triangular base prism, and oh, don't you love these ones? The surface area formula on your formula sheet says area of all sides. So in order to do this one, we do have to break it up. How many sides does this shape have? 5 of them. 1 triangle, 2 triangles, and 3 rectangles. Now we have to label the parts of each of these. So on your triangle, can you see that the height is 10, the length is 30? For your rectangles, you'll have 1 rectangle. If I do the bottom red one first, can you see that that one is 30 by 15? Okay. If I do this one that has the 10, it's going to be 10, and how long is this side over here? 15. And then now the one that we can actually see, that one's going to be 15 by, an unknown. How do you find that unknown? Do you see that this unknown, and I'm going to draw black dotted lines on it, and I'm going to go up to my picture, and I'm going to draw black dotted lines on it. Can you see that that is there? So the hypotenuse of the triangle. So there's no way we can figure it by looking at this picture. We'd have no way of solving it. But when we figure out where it is on our graph and realize that it's also part of our triangle, we can do a squared, whoa.
Wait, couldn't you just not add one of the rectangles, though? Because you're going to take it off anyway.
But which one?
The
The bottom one, not that one.
Yeah,
So
no,
we
not that one. I'm just saying, like,
we could. Okay, but we're still, we'll look at that as a shortcut afterwards. Okay? But I'm going to go to a squared plus b squared equals c squared. I have 10 squared plus 30 squared equals c squared. Whew. So 1,000 equals c squared. And this is going to be, to square root it on our calculator, I'm going to say 31.6. See how close that is. Square root 1,000, 31.62. Nice. And that's going to be this length here, 31.62, and I'm going to write it in here, 31.62. Again, when I'm doing my notes, you notice I'm switching colors. That way you can see where numbers come from. As soon as I wrote those black dots, I started working in black so you could see all the work that dealt with those black dots was right there. Mom, I'm in math class. Oh, a spam caller. Oh. Okay. So, we still haven't figured out the surface area in this idea. Base times height divided by 2. This one is 150. This one is 150. Length times width for here, we're going to get 450, 150, and this last one, we're going to need our calculator. Oh, I should have, but I saw it already. 474.3. So does it make sense that our surface area is going to be 150 plus 150 plus 450 plus 150 plus 474.3? Now, there's a lot of numbers. Did you get 1374.3 centimeters squared? Awesome. I'm going to put a circle around that one because that was our small idea number 2. I'm going to draw a line under this. And now,
is something like this going to be on our desk? Like,
yes. Yeah. This is as easy as the composite ones get.
As easy?
Yes. Because composite ones, like I could make, they get harder if we would go back to this. This would be harder because it has 1, 2, 3, 4 shapes on top of each other. The easiest these ones get is 2 shapes on top of each other.
But, like, on the test, is there going to be something with 4 layers? Like
No, just 2 layers like this. On your test, you'll have 2 layers just like this. So we've done big idea number 1, big idea number 2. Now we have to subtract 2 rectangles. So we go to this rectangle. What are the lengths on this rectangle? This one is 15 and this one is 30. So the area of that rectangle is 450. We can put the times by 2. once we go back now to the big idea, the surface area is going to equal the blue one, 2,700. Plus 1374.3, and then minus 2 times the 450, because you have 2 of those rectangles, one on the triangular prism and one on the... You could just say 900. So we go to our calculator and... Okay, it's going to be 3174.3. No? Okay, check it out. 2,700 plus 1374. Yep, I was right.
Oh, I would figure that out and just take 900 away from the
That's
1,300 and then just add the rest.
well, I took the 900 off of this because it would be easier. Made that 1,800 and added it to this 3174.3. But it's the same idea. Taking the 900 off of here is not bad, making it 474. But you have to remember more decimal places. That's why I took the 900 off of here. Because then it was just 18 plus 13 is 31, and all the decimal places. And it will be centimeters squared.
That'd be really funny if someone did that for all that work and then did that to centimeters squared.
Yeah, I have to take off a half a mark if you don't have the units. Quiz on this tomorrow. This is just practice. So this one is a little bit harder. Okay, so this, I told you on your test, I'll just give you 2 shapes. But if you practice one just a little bit harder, then you're able to do the ones on your test easily. I'm going to need to pull out 3 colors on this one.
Are we doing this one on our own or?
No, I'll do it with you. There's my blue shape. Yeah. Well, there's homework at the end for you to practice ones. So here's my big idea. The surface area will equal the blue shape. Okay? Plus my cylinder. Plus my triangular prism. Whew. Minus, can you see that if you dumped this whole thing into paint and then you broke the pieces apart, when you broke the green part off of the blue part, there would be a circle left. So we're going to need to subtract 2 circles. We're also going to need to subtract what happens when you pull off, yeah, I'm going to change that to orange. We're going to have to subtract 2 rectangles when that's taken off. Ugh. But I would say this one actually isn't harder, it's just longer, right? I could keep adding cylinders to all sorts of sides, and then I could put a tiny rectangular prism on. I could make a really crazy shape, say, dump it in paint, take it off, pull it apart, and it wouldn't be harder. Your big idea would just be longer, okay? And as questions get longer and longer and longer, they get a little annoying, but they're not harder, right? Because can you do each of these small ideas on their own? That's exactly the same as what we've been doing all along. There's just 5 small ideas this time. Idea number 1 in blue. Our rectangular prism. We have our surface area formula on our formula sheet. 2 length width plus 2 length height plus 2 height width. And we know that our height is 10 centimeters. Our length is 25 centimeters. And our width is 8 centimeters. If you want, I think you could work ahead of me. See if you can stay ahead of me and just check your answers as I put them up. That would really test whether you know how to do this.
Yeah, I did it, but I just don't want to calculate it, so I'm waiting for you to calculate
Oh,
it.
you don't want to pull out your calculator?
Can you do that in your head?
Is this right? I was trying. Yeah? Okay, thank you. Number 2.
Are you doing the cylinder?
Cylinder next, surface area, 2 pi r squared plus 2 pi r h. Look at the picture. Our height is 4 centimeters, and the radius is 6 centimeters. Notice that this time they didn't show us the diameter. They just gave us the radius directly. So, this one with pi, we'll need our calculator.
150.77.
Uh-oh.
Oh, never mind. Sorry. Just a second. Sorry. Carry on.
I was like, I typed it in I got 377 once it's rounded. Centimeters squared. Circle that one. Oh, I didn't circle my first one. Draw a line. Idea number 3. What color was I on for 3? Purple.
So just add all the sides. Or add all the areas.
Okay. Surface area formula for this one says take all of your shapes. So we would have, can you see that you would have 2 triangles and 3 rectangles. Well, one looks almost like a square, but we'll see what the measurements are. So we have on our triangle, this is 10 and this is 2. We have that, this would be 10 and this would be 2. On the rectangle that's on the end, can you see that height is 2? But it's supposed to be the complete length all the way across. It was hard to draw it on mine. So it's 2 by 8 for the square on the end.
Wait, how does that work?
Because the 2 is the height,
Yeah.
and the 8, it's supposed to go from one edge to the other edge. But there's a tiny line there that shouldn't be seen.
But it doesn't show that.
Well, this is what I'm saying. If I go to my diagram here, right, this length right here is the same as this length right there, which is the same as that length right there, which would make that 8. Okay? Now, which will be the same as this length right here, right?
Yeah. So
The bottom one is going to be easy. We can do that one. The bottom one is going to be 8 by 10. And the other one is going to be hard. It's going to be 8 by, and this dotted line is the same as your hypotenuse. So we have to do a squared plus b squared equals c squared. 2 squared plus 10 squared equals c squared. And 104 equals c squared. So c will be equal 10.1 or something. We'll try that out. Square root of 104, 10.2. Which makes this 10.2. We can now figure out each of these. Base times height divided by 2. Area of this one is 10. Area of this one is 10. Length times width, 80. Length times width, 16. Length times width, this one you have to take out your calculator. 81.6. So our surface area will be 10 plus 10 plus 80 plus 81.6 plus 16. (197.6 centimeters squared). Not yet. We got to do the red little idea was subtracting the circle. Area of a circle, pi r squared. We know that the radius was 6. Go to our calculator. 113.1. I find that these little ideas are pretty easy because they're just simple shapes. What's the area of our rectangle? Well, if we label the sides of the rectangle that's going away, it is an 8 by 10, right? Yes. So it would be 8 here, 10 here. So it's 80 centimeters squared. Okay. Draw a line there. 5 little ideas on this one. Now the big idea again. Our total surface area is going to equal the blue one, which would go up 1,060, plus our green one, go up 377. Plus our purple one, 197.6. Minus 2 circles minus 2 rectangles I could, but I don't feel like it.
Wait, for the surface area tip quiz, right?
Mm-hmm. 48.4. And we need our units. And circle that one. Again, how many marks is a question like this worth? Okay? If this was, let's zoom out here. Okay? If we think of this as a regular grade 9 math question and what I give you marks for, okay? I would give you a mark if you got the big idea down. Like, do you understand what the big idea is? Okay? Then figuring out the surface area of the prism is at least 2 marks for the blue one. So we're at 3 marks. Surface area of a cylinder is at least 2 marks. So we're at 5 marks. Surface area of the prism, at least 2 marks. Actually, it would probably be 3 marks because you have to do a squared plus b squared equals c squared. We're at 8 marks. The circle, 1 mark, 9 marks. This, 1 mark, 10 marks. Adding them all up, 1 mark. This could be like an 11-mark question. Okay? Generally, though, what ends up happening is sometimes these questions, because they're so big, and if a person leaves them blank, it hurts them too much, that they sort of go, okay, 1 mark for the blue, 1 mark for the green, 1 mark for the purple, even though it should be more. 1 mark for the red, and make it a 6-mark question. Let's see, how much did I? Oh, I got a fun one. Make sure you do this one on your quiz. There's one like this in your homework. Make sure you look at the one that's like this, where it's a rectangular prism with a cylinder drilled out. There's one like that in your homework. By the way, you just have to subtract the whole cylinder. No. You subtract 2 circles, but you have to add the. This is your quiz. Yes.
Wait, no, that doesn't make
It's not that.
sense. Wait.
So, let's just do the big idea for that. Okay? It's not that hard. You've got this. Okay? Big idea. Does this make sense that if, for the big idea, you could do the whole surface area would be the whole surface area of this, okay? Then, plus the surface area of the cylinder minus 4 circles, because you don't have the circles on the cylinder. You don't have the circles like. That's fine. Does that make sense? There's your big idea. Once you have the big idea, right? So this should be a 5-mark question. I only made it 3 marks on your quiz.
Is there any bigger question marks? Is there any?
So remember when we did the block questions? There's block questions on the cube questions. Oh, I have a cylinder on top of a cylinder. Okay, so that is your surface area quiz for tomorrow.